We're jumping into section 5 of Unit 4, and we are going to be talking about double distribution. You might be wondering, what is that? Double distribution. It's distributing a group by another group. And so first thing I want to point out is the difference between some things that we commonly look at and don't notice a difference between. So imagine you have group of stuff written plus group of stuff. So a polynomial plus a polynomial. This is an addition problem. And you might see a similar thing with subtraction. If there's a minus sign, it's a -1 that you would have up front that you distribute, and then you do addition. A different type of problem, a very different type of problem, looks like this. Exactly the same, except without the plus or minus sign in the middle. That is multiplication. Whenever you write two symbols together or two groups together, you are multiplying. And that also takes the form of distribution. So when you are multiplying or distributing, it's essentially the same concept. Distributing is just multiplying multiple chunks over each other. So multiplication is really what it comes down to. And so let's look at an example of a situation of how you might come across something like that. So let's say you have 2x plus 1 written directly next to 3x minus 4. It would be a situation where you do not have a plus sign in between. There is no plus sign, so because of that you know you're multiplying. And multiplying means distributing. So that means we need to identify what our chunks are in each of these pieces. So I have a 2x over here, I have a plus 1 over here, I have a 3x over here, and a minus 4 right there. I'm actually going to do different colors for those last two to just kind of highlight how those are a little bit different, or they belong to a different group. When I distribute, if you remember from section 4, we wrote down this rule of every chunk or term in the first group needs to be multiplied by every chunk or term in the second group. So that means that this 2x here needs to be multiplied by every chunk in the second group. And this plus 1 needs to be multiplied by every chunk in the second group. So you end up getting a total of 4 different terms that are going to come out of this 2 by 2 group multiplication here. So let's go ahead and write those out. And I'm going to take these little swoops away. We're just going to do one at a time so we can see where each chunk comes from. So let's go ahead and choose a different color for each of these. The first one, I'm going to take my first one times the 3x. 2x times 3x. And 2 times 3 is 6. X times x is x to the second power. Next term I'm going to get is that same 2x, but times the other one in that second group. So 2x times a -4. 2 times -4 is -8, and then the x. I've used up that first term with each of the second ones, so now I'm going to go to the next one. I'm going to say that plus 1 and distribute it to the 3x. So I'm going to do plus 3x. And then I'm going to do a final one, that plus 1 times -4, and that's just -4. After you've done all these steps, you need to go back and make sure that you didn't leave anything messy, as in, are there like terms that you could clean up? So I see I have an x squared term, it's the only one. I have a -8x and a positive 3x, so both terms with x in it. And then I have a constant, a -4. So cleaning these up, I'm going to have my 6x squared come first. Cross that out. A -8 and a positive 3. If I add those together, I get -5x. So I use those up. And then a -4 at the end. So that would be the way I would do that. Some of you may have seen something like this under the name of FOIL. We're not going to use that word. I think that it creates a lot of misconceptions. So we are going to stay away from that word. Don't say it ever. So we're going to do another quick example here of what happens when you have a bigger group that we're working with. Let's say you had something that looked like 5x squared minus 3y times 4x minus 2y plus 1. So if you had something like that, and I'm going to actually give myself a tiny bit more room to write above and below. If you had something set up like that, the same process applies even though there's more terms now than there was before. I'm going to circle each of my chunks in the first problem, or the first group, 5x squared, negative 3y. Do the same thing over here in the second group, 4x, negative 2y, positive 1. And I am going to distribute each of my first chunks to each of my second chunks. So I would take that 5x squared times 4x, and I would multiply that. I would take it times the negative 2y, multiply that, times the 1. Then on the underside, I would do the same thing with the negative 3y times the 4x, the negative 3y times the negative 2y, the negative 3y times the positive 1. The important part is that you go from each thing in the first group to every single thing in the second group. And then you multiply that out, clean it up just like we did before. I'm not going to work through that example. We'll see that later in the practice problems. But I just want to make sure that you saw that the two concepts were related. One thing that I do want to practice out all the way is when we run into things where we have something squared. So when you have something to the second power, that is the same. I want you to just write it the way I'm writing it with the squiggles in your notes. That is the same as taking that thing that was in the parentheses times itself. It's the same as taking that thing times itself. What we typically like to do, I'm going to use an example now with numbers, and write in front, never do this. Where we have something like, let's say x plus 5 squared. If we were to say, oh, that's x squared plus 5 squared, I'm just going to distribute that square. If you were to do something like that, you would be breaking a lot of the rules of math. Never, ever, ever do that. So we're going to write that and put a big no, never do that, and then underline never, never, never. In fact, if I see you do that, I'm going to take away health points, -5, every time you do that. So every time you feel the urge to distribute a square across an addition sign or across a subtraction sign like that, resist that urge. This is going to be one of the most difficult temptations you're going to face in this class. So never, never, never do it. Instead, though, let's look at what we can do. Let's frame this in the positive. Let's say we have something like x plus 5 squared. What it does equal is, just like we did up here, where we have the something squared means times itself. Let's write it out. X plus 5 times itself, times x plus 5. And remember, times, we just write it together. We don't need to put a symbol, a time symbol in between if we don't want to. So x plus 5, x plus 5. And now we're going to treat this just the way we would treat any other distribution problem, where we're going to circle our chunks in the first piece. We're going to circle our chunks in the second group. And then we're going to distribute out across each one to each one. So the x times the x is going to be x squared. The x times the positive 5 is going to be plus 5x. On the underside, we've got the plus 5 times x. That's going to be plus another 5x. We've got the plus 5 times the plus 5, so that's 5 times 5 is 25. So we end up with this. And then we remember that we always have to do combining our like terms, starting with the highest powers. So we have an x squared, we have an x term, another x term, 5 and 5, and then we have a constant, just a number, the positive 25 at the end. So cleaning that up, we just have plain old x squared. 5 and 5 combined together to make positive 10x, so we're adding those. Those are all used up, and then we just have plus 25 at the end. So that would be our cleaned up answer for x plus 5 squared. Taking a step back, if we compare that to the thing that we're told never to do, we have an x squared in both of them. We have a 5 squared. The 25 is just 5 squared. The thing that was missing from the thing that we're never supposed to do is that middle term right there, that 10x. So if you're not careful to write this out like this and you just assume that you can distribute a 2 across addition, then you are going to end up missing that middle term, which is going to change the result of the problem. All right, good luck with section 5.